Alright, here I am with the chapter 8 test review. That's for C302. Alright. Couple of things that you need to be aware of in this particular, for this particular test are concept of density. What is density? Density is mass over volume. So if you can figure out the mass of an object, if you know the mass of an object and if you know the volume, you can find the density. Now the volume sometimes could be given in terms of dimensions. So if you have a block like that, then you have volume is length times width times height, and make sure that all these are in meters, and then you'll get the volume in meter cube. Once you have the volume in meter cubed, then you can find the density as mass over volume should be in kilogram per meter cubed. Okay, just take care of the units. The density's unit is that. And then we went over the concept of, well, you can be given more questions on this. If the density is mass over volume, then cross multiplying it, you get mass is volume times density. So if you're given the volume and the density, you can figure out the mass. Or if you single out the volume, volume is mass over density. So if you're given the mass of the object and the density of the object, you can figure out the volume of the object. So any of these equations can be used. For example, all right, that's one of them. All right. Then came the pressure concept. What is pressure? It's force over area. Pressure is force over area. So if you know the force and the area, you can find out the pressure. Simple as that. Okay, the force must be in Newton and area must be in meter square. So you'll get Newton per meter square. Or if the force is measured in pounds and the area is measured in square inches, then you can actually get the pressure in pounds per square inches, which is what we write as PSI, pounds per square inches. But this is the SI unit of pressure. Since pressure is force over area, force is pressure times area, cross multiply again. This simply means that if there is a pressure applied on a certain area, so if this is the area, if there's a pressure applied from here, then if there's a pressure P1 applied from here, then there's a force in that direction, and that will be F1. So the force F1 is going to be P1 times area. Now, if there is another pressure from here, say, let's say a larger pressure, P2, then the force from that side, F2, will be P2A, because the product of pressure times area. So which means there's a force from here and there's a force from there, and that means there is a net force in that direction. Okay? There's a net force in this direction. So if you are told to find the net force, what you need is the pressure difference between here and here. So if you want to find the net force, you can just take the pressure difference, which is P2 minus P1, and then multiply by area. So this is the net force. This is the net force, pressure, the pressure difference times the area. Okay, and then we went over the tire pressures. The tire pressure, what the gauge reads is the pressure, it's called the gauge pressure. What the gauge reads is the gauge pressure, which is the difference between inside and outside. Inside and outside. Outside is normally the atmospheric pressure, but inside is the absolute pressure. Inside pressure is absolute pressure, outside pressure is atmospheric pressure. The difference between pressure inside minus pressure outside, pressure inside minus pressure outside, that is gauge pressure. Okay, the difference between inside and outside is going to be gauge pressure. So whatever happens to the outside pressure, it is the gauge pressure that this gauge is going to. Then we went on to pressure in liquids. Pressure in liquids, if you go deeper into a liquid, the pressure down here is going to be greater than the pressure from here. This is the pressure on the top, this is the pressure down here. The difference between this pressure and this pressure is a gauge pressure, which is the pressure of the liquid, which is density times the gravity times the height. So the height means the depth. So as you go deeper in a liquid, the pressure increases. And of course it depends on the density of the liquid also. It depends on gravity, it depends on the height. Okay, and then we went on to studying the Pascal's principle. And what is Pascal's principle? Pascal's principle is, we learned it through the piston thing. So when there's a force F1 here and the area is A1, and there is the force F2 here and the area is A2, according to Pascal's principle, pressure is transmitted throughout the fluid. So that means the pressure everywhere is going to be the same. Therefore, F1 over A1 is F2 over A2. So if you know at least three of these things, you can find the fourth one. Now area is the area of this piston. Now sometimes the area can be a circular area. In that case, area is pi r square. Okay, area can be, so if you are given the radius, then you can actually figure out the area that way. A solid transmits force, whereas a fluid transmits pressure. A solid transmits force. So if I take a meter stick, and if I push the meter stick from here at 10 newtons, the force that is felt over here is also 10 newtons. That is, a solid transmits force, but a fluid transmits pressure. So you can apply a small force here, but you can get a big force on this side. That is the concept that is used in hydraulic lift, hydraulic press, car brakes, and all those hydraulic applications. That is where Pascal's principle is coming into it. And the other concept is Archimedes principle. What is Archimedes principle? Archimedes principle says if an object is partly or fully submerged in a fluid, then it experiences a buoyant force. The buoyant force is equal to the weight of the fluid displaced, which is equal to the mass of the fluid displaced times gravity, which is also equal to the density of the fluid displaced times the volume of the fluid displaced times gravity. So all this is basically Archimedes principle. Buoyant force is weight of the fluid displaced is equal to mf, which is mass of the fluid displaced times gravity, which is density of the fluid displaced times volume of the fluid displaced times gravity. So you may be able to use any of these things as part of a problem solving step. Based on this, you can have some questions where if you are given the volume of the fluid displaced and the density of the fluid displaced, you should be able to find out the buoyant force. A typical problem that you can think about here is, let's say an object weighs some mass in air. Suppose it weighs 10 kilograms in air. And then when it actually goes into liquid like water, it weighs less. So when it goes into a liquid, let's say it weighs um, 8 kilograms. So if it is weighing 8 kilograms in a liquid, that means immediately we can understand that the buoyant force was definitely coming into play, and according to buoyant force, it is equal to the weight of the fluid displaced, and in this case we are talking about masses. So how much mass of fluid was displaced is the difference between these two. So the mass of fluid displaced is 2 kilograms. So if the mass is 2 kilograms, then the buoyant force is 2 times 9.8. So the buoyant force on this block right now is 2, which is the mass of the fluid displaced, times gravity. Okay? Now, how much is the mass of the fluid displaced here? The mass of the fluid displaced, which is water, mass of the water displaced is 2 kilograms, which is actually 2000 grams. Now, you know, since it is water, as water's density is 1 gram per centimeter cube, if you see 2000 grams of water is displaced, it must be 2000 centimeter cube for the volume of the water displaced. If the volume of the water displaced is 2000 centimeter cube, then automatically why is this much water being displaced? It's because the volume of the object is the same, 2000 centimeter cube. So the volume of the object is 2000 centimeter cube. It is something that we understand from the previous step, because if so much water is displaced by the object, then it should be equal to this volume. Now you know the mass of the object is 10 kilograms and the volume of the object is 2000 kilograms. We can figure out the density of the object, which is mass over volume. Mass of object over density of volume. So you see 10,000 grams. See, this is in kilograms, so you have to change it to grams over 2000 centimeter cube. And therefore you get the answer of 5 grams per centimeter cube as the density of the object. If you want to convert it into kilograms per meter cubed, you can actually write it as 5000 kilograms per meter cubed. Okay, this is how we solve it, by just conceptual information and no ready-made equations. Now, what happens when the same object goes into another fluid such as oil? When it went into oil, it weighs 8.5 kilograms. So if it weighs 8.5 kilograms when it went into oil, then what is the density of the oil? So if it weighs 8.5 kilograms when it went into oil, then what is the weight of the mass of the oil? I mean, what is the density of the oil? So what you can do now is go back again. It was weighing 10 kilograms, now it weighs 8.5 kilograms, which means the buoyant force is 10 minus 8.5, which is 1.5 kilogram of oil displaced. If 1.5 kilogram of oil is displaced, that means mass of the oil displaced is 1.5 kilograms. And you know, mass of oil displaced is that. Mass of oil displaced is density of oil times volume of oil. But the volume of oil is the same as this volume. This volume is this volume. Because how much volume of oil is displaced is exactly as much as the volume of the object that goes inside. Therefore, we know this. We know this. We can figure out this. So, mass of oil, so 1.5 is equal to density of oil times 2000. But again, this is not 1.5. You should write it as 1500. Because 1.5 kilograms is 1500 grams. So, if you want to keep the same system of units, this is a better way of doing it. So, density of oil is equals to 1500 over 2000. And the answer comes out 0.75 gram per centimeter cubed. Okay. 0.75 gram per centimeter cube in terms of kilogram per meter cubed is 750 kilogram per meter cube, because you just multiply by 1000 to change from gram per centimeter cube to kilogram per meter cube. Okay. Now, if the density of oil is already given to you, and if you are supposed to find the mass of the fluid displaced, or how much it weighs in oil, or some other question, then you have to just basically use the same equation with the different unknowns. But understand that the volume of oil displaced is the same as the volume of water displaced, which is the volume of the object. Okay. And then we went over other stuff in this chapter, which is related to floating. Okay. If something is floating, let's say for example, an object is floating in water. So if an object is floating in water, it's floating in water because the weight of this much volume of water displaced, that's a buoyant force. That buoyant force is equal to weight of the object. So if these two are balanced, then it floats. Now based on this, we can actually figure out more information, like you can actually get problems based on this. The concept is this. So if you're talking about a wooden block, so if a wooden block is, like if you're given the dimensions of the wooden block, okay, so here is a wooden block. If the dimensions are given to you of the wooden block, let's say this one is 0.4 meters, and if that one is 0.2 meters, and that one is 0.1 meter. So if you are given this kind of a slab of wood, and if you are given the density of wood, let's say is 600 kilogram per meter cube. So if you're given the density, and if you have the dimensions, can you find the mass of the object? The mass of the object is volume times density, and the volume is length times width times height times density. So length is 0.4, width is 0.2, and height is 0.1, and then density is 600. So if you multiply all these things together, you should be able to see that it is 2.4 kilograms. That will be the mass of the block. Just for confirmation, 0.4 times 0.2 times 0.1 times 600 equal to, oops, wait a minute. Oh, it is, I forgot that. So it's 4.8. So 4.8 kilograms. There it is. Yes, 4.8 kilograms is the mass of the object. So what is the weight of the object? The weight of the object, 0.8 times gravity. This is the weight of the object. Now, if that object is going to float like this, so if this object is going to float like this here, what you should understand is the weight of the object is equal to the buoyant force experienced by the object, because the object is going into water and displacing this much water. So weight of the object is equal to the buoyant force. That is a main condition in buoyancy, in flotation. So weight of the object is 4.8 g. G stands for gravity. And the buoyant force, which we saw earlier, The buoyant force is the weight of the fluid displaced, which is this. So density of fluid times volume of fluid times gravity. Gravity cancels off. Gravity cancels off, and you may be wondering why the whole thing appeared all of a sudden. I'm just redoing it because the video didn't turn up right. So okay, so as G cancels off, you can see 4.8 is density of water. This is water, which is 1000 kilogram per meter cubed. Kilogram per meter cubed. And times the volume of the fluid displaced, which is this bottom part. So if you calculate the volume of fluid is 4.8 divided by 1000, so you get this as the volume of the fluid displaced. And volume of the fluid displaced is only from the bottom section here. Remember, the volume is area times height. This is a very important thing. Volume is area times height. The area of the base times this height is a volume. So this volume is area times the height, or length times width times height. You know, length times width times height is volume. So this volume is area times height, and the area is 0.4 because the width is length is 0.4, and this is 0.2, which is right there, times height, and you should be able to calculate the height, and we find it is 0.06 meters. If the height here is 0.06 meters and the whole thing is 0.1 meter, you can actually figure out how much is going to be above the water. Okay, which is 1 minus 0.06, which is 0.04. So this is the amount of this is the amount that is underwater, and 0.04 must be above water. So if you're given any of these things, you should be able to figure out the other. For example, if you're given this height instead, and can you find the area? Yeah, you just use the same equation and work it out. Volume is equal to area times height is an important equation. Yes, so another concept you can understand from here is how much of the volume is inside. So what is volume? Volume is equal to area times height. So the bottom area times height, you can see that here. This is the area. So volume is area times height. So if you know the volume and if you know the height, you should be able to find the area of the bottom. So understand that that is the equation. This is basically the same thing as length times width times height. Length times width becomes the area. So that becomes the area. Okay. And the other concept that we have gone over, one of them is the equation of continuity, which is A1V1 is equals to A2V2. That's the equation of continuity. So wherever the fluid is actually kind of getting narrowed down, it should go faster. So if a fluid is going like this and then getting narrowed down like this, so the fluid over here is going slow, over here is going really fast. Because the area here is big and so it's going slow, the area is small and so it's going really fast. Okay? So this is the equation of continuity, a concept that you should be aware of. The other thing we did in the same chapter is Bernoulli's principle. Bernoulli's principle actually says wherever the fluid goes fast, the pressure is low. Wherever the fluid goes fast, the pressure is low. And so we went through all those Bernoulli's principle examples, like the plane in the air, what is actually helping it to stay afloat is the Bernoulli's principle. We also saw the aerator or a paint can or perfume spray, all those things work on Bernoulli's principle. And so yeah, Bernoulli's principle works on pressure difference created. So we saw the curve ball, we saw the ping pong or tennis or golf, you know, all those places where there is curving of the ball. That's all Bernoulli's principle. So we went through Archimedes principle, which basically is telling you why the ship is floating, and all those related concepts. And if something is We went through Pascal's principle, which is basically how car brakes work, and hydraulics work. All those heavy machinery works with Pascal's principle. We went through flotation. We went through, yeah, flotation is part of the Archimedes principle. Yeah, so these are all things that we have done in this chapter, and you should be in a position to do the test well. So good luck with the test. Just make sure that you're doing calculations right, and do it as best as you can. All right. Good luck. Good luck.